In this video, we're going to look at finding limits of functions using the numerical method. So in the last video, we looked at the graphical method where we used graphs of functions and visually looked at what the limit was doing. In this case, we're going to take the function and use values of the function to determine where the limit is going. Okay. So here, let's look at this first limit. The limit as x goes to 0 of x over the square root of x plus 1 minus 1. Okay, so to use the numerical method, basically what I want to do is I want to find values close to x as they get closer and closer to 0. So I'm going to pick a couple of them, and then find their function values, and based on what those function values are, determine what my limit is. Okay, one of the things to keep in mind is as I'm doing the numeric method, again, I need to take into account both sides of the value. Okay? So in this case, because we're looking at 0, I want to pick values of x that are going to 0 as I take my limit. So I'm going to start out with the negative side. Let's start at negative 0.1. Because I want something close to 0 but not quite 0. And then I want something a little bit closer. So I'm going to take a negative 0.01. So I'm getting a little bit closer from the left. And like I said, we want to do a couple of these. I would say probably about 4 of them is enough so that you can figure out what it's doing. There are some cases where you might need a couple more points. Okay? And so this is from my left side. Okay? And then we're going to find the f of x's. And then likewise, I want to do the same thing from the right. I want to look at some x values from the right and figure out what their values are as I get closer and closer to 0. Now 0 is nice. I can basically just mimic the values I chose for the negative side, but then, adjust them by taking off the negative sign. Okay. So now I need to find the function values. This method is one of the few methods that you will actually need a calculator in order to simplify. And so when you're doing your homework, you are encouraged to use a calculator to find these. I don't expect you to do these by hand. If you're looking at an exam or something we're doing in class, there is probably a better method to use. Okay, so your numeric method should probably be a last resort. Okay. So here, if I look, now all I'm going to do is I'm going to take these x values I got and plug them into the corresponding function and find their values. So if I put in negative 0.01, we can see I'm going to get a 1.94868. And I'm just going to round these to 5 decimal places. For this one, I'm going to get a 1.99499. Here we get a 1.99950, and for this one I'm going to get a 1.99995. Okay? Now I'm going to do the same thing with the right hand side. So looking at the positive values, if I plug them into my function, I'm going to get a 2.0488, 2.00499, 2.0005, oops, sorry, and 2.00005. Okay, and so now I'm just going to look at what these numbers are doing. So in both cases, as I move to the right on the table, I'm getting closer and closer to 0. So in this first table, I can see as I move across the table in this direction, coming in from the left side of x, my values start at about 1.9, and then they increase to about 2. Okay, so I rounded them off to 5 decimal places, but if I actually look at the number, it's pretty close to 1.95 and about 2. Okay, here, again, as I move across the table in this direction, I'm getting closer and closer to 0 from the right. So coming in from the right-hand side of 0. Here, my values start at about 2.1, give or take a few. And as I move across the table, they're getting closer and closer to 2. So here, this means that my limit as x goes to 0 of x over the square root of x plus 1 minus 1, that limit is 2. Let's look at another one. Okay. So for this one, we're looking at the limit as x goes to 0 of cosine of 1 over x. And so again, like the other, I'm looking at something going to 0. Again, this can happen for any number. But now I'm going to look at a trig function. Okay? So the same thing is going to happen. I want to look at coming in from the left and again coming in from the right. And for both of them, I want to pick some x values and find their corresponding function values. Okay? And so here, since I'm going to 0, I'm going to use the same values we chose last time. So 0.1, 0.01, negative 0.001, and negative 0.1231. Okay, and on the positive side, same thing, just no negatives. Okay, so again, probably going to need a calculator to simplify this down. So I already kind of did these up ahead of time, but plugging in my values, so at 0.1, we're going to get a negative 0.8391. That's 1. For the second one, when I plug it in, I'm going to get a 0.86232. For the next, we get a 0.562379. And then for the next, we're going to get a negative 9.95215. Okay. Now we're going to do the same thing with the right. So I'm going to take these values, plug them into my function, and see what I get. And so, oddly enough, when I plug in, I'm going to get the exact same values. And maybe it's not so odd if I think about it. Right? If I think about what the cosine function does, it's periodic. So on one side of the y-axis, I get the exact same values on the left side. And so here we can see that periodic behavior happening in the numeric values. Okay? But now we need to determine what the limit is doing. Okay? So we're going to look at the values and figure out what they are increasing or decreasing to. Well, in this first one, if I look, I start out with something negative at about negative 0.9 or 0.8, we'll round off. Then I go up to, well, about positive 0.9. I start decreasing to 0.6 and keep decreasing to something negative. So negative 0.1. About a negative 1. Okay? So unlike the last one, I'm not steadily increasing towards one thing. It looks like it's decreasing, but here, if you happen to pick another value, you'll find that it starts increasing again. And again, that's because of the periodic nature of our cosine. We know that after it reaches negative 1, it's going to start going back up towards 1. And so here, as I get closer and closer to 0, this value, so in this case, as I move across and it starts to go back up, I can see that the limit doesn't go to one value. It kind of oscillates as those values get closer and closer to 0. Okay? So here on the left, the limit does not exist. But if we noticed, we had the exact same values for the right-hand side. So again, I'm seeing the same behavior. It's going to start out negative and decrease down to the lowest point, and then it's going to start increasing again. And so here, our limit does not exist. And so unlike what we saw with our graphical video, this is the one case where if my two one-sided limits are the same, then my function value, or my limit, my two-sided limit is equal to those. And in this case, this just means that my limit as x goes to 0 of cosine of 1 over x does not exist. Alright, let's look at one last one. So here we're going to look at the limit as x goes to infinity of 3 over 2 minus e to the x. Okay, so here basically what we're going to do is the same thing. The difference is now I'm looking at kind of an infinite limit. I want to know what happens as my x's go way out. Okay, so here I don't need to look at both sides because if I'm going to infinity, I can't really come in from the right side of infinity. So we're only looking at coming in from the left. So again, I'll pick some x values and then look at my f of x's. Okay. And so here, as I'm going to infinity, I just need to see what happens as my x values get bigger. So I'm going to start with a 1, and then we'll go to 10, and then we'll go to 100, and then we'll see about 1,000. Okay. So they're getting bigger, and I can kind of get an idea. And again, in some cases you might need a couple more points to figure it out or see the pattern or not see a pattern, but 4 should be mostly sufficient. So now I'm just going to take these and plug them into my function. So at 1, I'm going to get a negative 4.177. At 10, I get a negative 0.001. At 100, I actually get a negative 0.000001. Okay, and for most of you, if you try plugging 1,000 into your calculator, most of you are going to get some kind of an error message. And that's because as my numbers get bigger, I can see these are getting small very fast. And so the larger I put in, the much smaller it's getting much too quickly, and it's hard for it to calculate it. And so here, what this is telling us is that even though the numbers are getting smaller, they're getting smaller towards 0, not towards negative infinity. So they're not getting more negative, they're just getting smaller. And so here, our limit as x goes to infinity of 3 over 2 minus e to the x is just going to be 0.